Okay, so our question is how to classify our alkyl groups. Alkyl groups are always classified by the number of carbons that are attached to the alkyl group's carbon that's attached to the parent chain. Okay, it's a mouthful. Let's go backwards. What's the parent chain? In this case, it's this R. It's the R and it's the R. So everything else is actually classified as a substituent. Okay, so if this is the substituent, another way to say that is alkyl group, substituent, same thing. But some substituents are not alkyl groups. So like bromine would be a substituent that is not an alkyl group. Okay, so in the substituent, we have two carbons. One of those carbons is directly attached to the parent chain. That's the one we want to look at. And we want to say how many groups is this carbon actually attached to? Well, it's attached to the parent, but we don't count that. So we're looking at how many alkyl groups are attached to the carbon that's attached to the parent chain. So in this case, there's one. The other two are hydrogen bonds, so we call it primary. Go to the next one. Here's our parent. So all of this is substituent. Here's my carbon. It is attached to two other carbon-containing groups. The fourth thing that this carbon is attached to is a hydrogen, and we don't count that. So there are two carbons attached to the carbon in the substituent that's attached to the parent. So that makes it a secondary alkyl group. Go to the last one. Here's my parent. This is all my substituent. Here's my carbon that's attached directly to the parent. It has 1, 2, 3 other carbons attached to it. So this is the common way to classify them. Now, let's talk about each group individually. Let's talk about an ethyl group. An ethyl group only has 2 carbons. So here's my parent, and I have 1, 2 carbons. Look at the carbon that is directly attached to the parent, and I see here that there's 1 other carbon attached to it, so that makes it primary. There is no other way that I can arrange this that would give me anything other than a primary substituent. So we just call it ethyl, nothing special about it. Same thing with methyl. There's only 1 carbon, so there's nothing else attached to it. So it doesn't even get classified as primary, secondary, or tertiary. Propyl and butyl groups you have to worry about it. So you have to know how to name it. So if the substituent is hooked to the parent in a straight chain, all we say is propyl. This tells me that it's primary because if I look here at this carbon that's attached to the parent, there's only 1 other carbon-containing group attached to it. The rest, and I'm not showing it here, are just hydrogens. So I don't show them here just because it takes up so much space and it really gets confusing. So this R is the parent, and then what's attached to it is the substituent. So straight chain, nothing special, just name it propyl. There's 3 in a branch, so it's a propyl. Here's another example of 3 in a branch, but I can make the carbon that's attached to the parent a secondary carbon by moving this last carbon and attaching it to the first one. So I no longer have the last carbon here, it's attached to the first one. So I can call it one of 2 things. I can pretend that this is a parent, but it's really not. But I can pretend that this is a parent chain. So 2 carbons in the parent chain would be ethyl. And then 1 methyl group coming off of carbon 1 would make it 1-methyl. So instead of calling this 1-methyl ethane, because it's still a substituent, we call it 1-methyl ethyl. The other way is if you look at this and at the very end, you see this like Y shape, right? That tells me that you have an isopropyl. So you have a carbon here, and a carbon here. Now, the number of carbons in this chain will depend, right? If you only have 3, so if it looks like this, and this is the R group, then this is isopropyl. But if I were to change this and put another carbon and attach it to an R group, this would be isobutyl, butyl, right? So it's all about how basically it looks, not about whether it's secondary or tertiary. Okay, butyl. 4 in a branch. If They're in a straight chain. That first carbon's primary, we're going to call it butyl. If I do that same thing where I took this carbon and I move it to the first carbon, now that first carbon is a secondary carbon. I could name it, pretending that these three are a parent chain. 3 would be propyl and a methyl coming off the first one. So that's my 1-methyl. Or I name this sec-butyl because this carbon is a secondary carbon. It is not isobutyl because I don't have that Y shape at the end, right? This would be a shape like this. It would be 2, 3, and then 1 coming up here, and then 1 going to the main chain. So it looks different. This is sec-butyl, okay? All right. Now, if instead of me taking this carbon and attaching it to the first one, if I take it and attach it to the second, now I'm going to make that Y shape where I have 1 carbon, 1 carbon, 1 carbon. There's the tip of my Y, and then I come down and I have another carbon in the R group. That is isobutyl. Or I could name it, pretending it's a main chain. There's 3 long, that's propyl. And then coming off of carbon 2 is a methyl, that's 2-methyl. Lastly, I could take either one of my secondary or tertiary and take that third carbon and move it, right? So if I take this third carbon and I move it to position 1, then that's tert-butyl, because I'm going to have a carbon. Why did I do that? 1, 2. Oh, this is another 2. Why do I have that labeled as a 3? This is another type of secondary. This is my tertiary. Okay, so we call it tert-butyl because it's tertiary, and it kind of makes a T. That's how we kind of look at it, right? It kind of makes a T. But this third group, right? This third group moved on to carbon 1, which means that carbon 1 has 1, 2, 3 things attached to it, which makes it tertiary. So you could just call it tert-butyl, T-butyl, or you could say, here's my main chain. My main chain has 2 carbons in it, 1, 2, and then coming off of carbon 1, I have a methyl group, and coming off of carbon 1, I have a methyl group, so that's 1,1 dimethyl. Okay, hope that helps.